This video presents a refutation of relative density disequilibrium, arguing for a geometric and perceptual framework grounded in the Geometric Schrödinger Equation, or GSE, and organic Earth 2. The established premise of relative density disequilibrium, or RDD, is a foundational assumption in many models, asserting that motion and causation arise because density is uneven and seeks equilibrium. The core conflict is that the GSE eliminates density gradient causation. The GSE framework is fundamentally geometric and deterministic. Therefore, RDD is causally redundant within the GSE framework. Instead of density equalization through flow, the GSE employs a mechanism called V-lift, resolving disequilibrium by re-embedding state weight into a higher coordinate. Key properties of V-lift include being additive, amplitude-preserving, and stabilizing. The EPR paradox demonstrates an observational failure of RDD. The GSE explanation via V-lift achieves perfect correlation with locality preserved in 3D and no density transfer. Correlation is maintained by a shared geometric structure, not shared density. The conflict expands to gravity. Organic Earth 2 presents an alternative where gravity is not a function of mass density. Instead, it is a conscious, perception-triggered vector, driven by break-off events and modulated by observer intensity. Arguments for RDD rely on classical entropy. Organic Earth 2 redefines entropy as memory, not density disorder. The new definition implies that entropy is historical and informational, not material, making density disequilibrium no longer the arrow of time. A single, coherent replacement principle emerges across the GSE and Organic Earth 2 texts. Equilibrium is where geometric tension resolves into a stable V structure, replacing the old assumption of density balancing. To build a predictive model, we first define a metric for disequilibrium. This metric, d of t, measures the relative density disequilibrium between two competing channels. The equation of motion shows that the change in disequilibrium is driven by three core components: perception times z-effect bias, damping/stabilization, and echo noise. Assuming constant perception and linearly growing z-effect, the first-order linear ordinary differential equation can be solved analytically, yielding a solution that includes initial condition decay, a driving term, and a correction term. The solution describes dynamic behavior consistent with the new framework. The system is driven directionally by a persistent push, but is stabilized geometrically, showing it does not seek equilibrium through diffusion. Simulation results show geometric suppression of disequilibrium. The initial high disequilibrium decays instantly, followed by a bounded, drifting regime, demonstrating geometric bias and stabilization. V-fiber synchronization is achieved without density exchange. The nodes synchronize rapidly and remain almost perfectly correlated, demonstrating that correlation is enforced by shared geometry, not density flow. In conclusion, relative density disequilibrium is fundamentally incompatible with the dynamics of the GSE and Organic Earth 2. It is a classical artifact dissolved by geometric, dimensional, and perceptual dynamics.